10. 10, 10, 10. Okay, and who else do we have? Tanapat. Tanapat, can you hear me?
Yes, teacher.
Good. Okay, what do we have? Why do we have only 5? 5 is not enough. Did you guys finish eat lunch? Good. Im. All right, guys. Well, let's get started. So last time we started talking about substances. And there's 3 different states that we can have substances be in. Does anybody remember what those 3 different states are?
Solid, liquid, gas.
Yes, that is correct. Okay, so we have solid, liquid, gas is the 3 different states. So what do we call if we get a solid go into a liquid? So when a solid changes into a liquid, what do we call that process,
Melt.
that change? Say
Melt.
again. Melt. Yes, that is correct. Okay, so let's say we have ice and it's get hot. The ice will melt and become water. Okay, what do we call when a liquid become a gas? Let's ask somebody else. Raksit. Raksit. Can you hear me?
Yeah.
So what do you call it? Let's say we have water and it's become water vapor. Do you know what is the name?
Water?
Yes, it's water, but when water is become like a cloud, right?
Yeah.
What do you call when water becomes cloud? It's like, let's say your shirt, yeah, your shirt gets wet, a lot of water on your shirt. So you hang your clothes and then it's get not wet anymore. The water goes
Me.
away. It,
Me.
yes,
Evaporate. Evaporation.
yes, it is
Yeah.
evaporate. Okay, so when the
Yeah.
water becomes gas, it's become cloud. We say evaporate. Evaporate. That's it. Can you say it? Evaporate.
อะไรนะ
Evaporate.
Evaporate.
Okay, good. All right, guys, and the last one, when a gas. I know it's not the last one. Let's go for the other way. So when a gas becomes a liquid,
Condense.
it is condensed. And when a liquid become a solid, let's ask Watikon. Watikon, can you hear me? Can't hear you. Okay, well, it is called freezing, guys. So when water becomes solid or ice, it is freeze. Okay, how many people do we have here? 1, 2, 3, 4, 5, 6. Still only half. All right, guys, so today we're going to carry on with substances. Substances and mixtures. Okay, guys, a substance is matter that is always made up of the same combination of atoms. Okay, guys, so atoms is like the smallest little piece that everything is made up of. And a substance is always made of the same combination of atoms. So the smallest things that make up a substance is always the same things for every different substance. Okay, guys, there are two types of substances. They are called elements and compounds. Elements and compounds. Composition of elements and compounds doesn't change. Therefore, all elements and compounds are substances. Okay, guys, so they're just saying the same as what they said before. So elements and compounds, those are the two different types of substances. Okay, so we're going to learn now what is an element and what is a compound. Okay, guys, here we have examples of some elements. Chlorine, oxygen, carbon. Okay, guys, so these are three different kinds of elements. In chemistry, we write them with a symbol. So chlorine is big C, small l, and then a little 2 on the side. We say Cl2, chlorine. Okay, oxygen is a big O with a small 2. We say O2, or oxygen. Okay, and carbon is just a big C. Big C carbon. Okay, guys, on the other side, we have compounds. So what a compound is if you have two or more elements that are joined together, they form a new, something new that is called a compound. So the first one we have is sodium chloride. Okay, guys, so on this side, you can see there's just chlorine, Cl2. And on this side, we have NaCl. So the Cl is the same, the chloride. So it's 1 chlorine plus 1 sodium, NaCl. And that's what a compound is, guys. So if you join two elements or more elements together, we get compounds. Okay, water is H2O. Is mean 2 H's plus 1 O together, and they're bonded together is form water. Okay, and then methane. Methane is a type of gas. CH4. Okay, so the C in that is the same as carbon. So it's 1 carbon and 4 H, 4 hydrogen. Okay, does everybody understand? Or Mike out Jai?
เข้าใจ
Out Jai. Okay, good. Matter. Okay, guys, so matter. Anything that has mass and takes up space. Okay, guys, so what that means is if something has mass, it means you can weigh it. So, like this bottle, for instance, right? I can put it on a scale, and the scale will tell me how heavy it is. And that is going to be its mass, how much it weighs. So anything that has mass and takes up space. Okay, so takes up space means it needs to exist in space. It needs to take up space. So again, like this bottle, it's take up the space of a bottle, and it weighs however much it weighs. So that is matter. Okay, guys, so things that are not matter is something that does not have mass and it doesn't take up space. Okay, so that's going to be stuff like energy, different types of energy. Most matter on Earth is made up of atoms. Okay, guys, so matter is different to substances. Matter is like everything, is all. Substances is only specific stuff, elements and compounds. Matter with a composition that is always the same, or two types of substances, elements and compounds. Okay, guys, so on the left we have elements. Consist of just one type of atom, organized on the periodic table. Elements can exist as single atoms or as diatomic molecules, two atoms bounded together. Okay, well, so what that means, guys, is sometimes you can have two of the same together. Like for oxygen is O2, is mean two oxygen together. Okay, on the other hand, we have compounds. Two or more types of atoms bonded together. Can't be separated by physical methods. Properties of atoms, properties of compounds are different from the properties of the elements that make it up. Two types, ionic and covalent. Okay, don't worry about that too much. Okay, guys, the next thing we have is a mixture. Okay, so a mixture is different to a substance. A mixture is two or more substances that are physically blended but are not chemically bonded together. Okay, guys, so a mixture, if you put two different things together, they mix together, but they don't become something new. They just mix together in different levels. That's what a mixture is. The relative amounts of each substance in a mixture can vary. Granite, a type of rock, is a mixture. Granite contains bits that are white, black, and other colors. Two pieces of granite will have different amounts of each color bit. The composition of rock varies. Okay, guys, so what they're saying is granite is a type of rock. You can see in the picture here, there's two different pieces of granite, and they look a little bit different. The one has got a little bit more white and the one's got a little bit more black spots. So they're saying that mixtures can be different. The amount of stuff in a mixture is different. Air is also a mixture. Okay, guys, so air, what we breathe, is a mixture. It's got different things mixed together. Okay, air contains about 78% nitrogen, 21% oxygen, and 1% other substances. Okay, guys, so these other substances is a bunch of other different things, but it's only 1%. So don't worry too much. Okay, this composition varies. Air in a scuba tank can have more than 21% oxygen and less of the other substances. Okay, guys, the last thing we need to know is heterogeneous and homogeneous. Okay, guys, so what you actually need to know, this part here, hetero. Hetero is mean different. So things that are different. On the other hand, this one, homo. Homo is mean same. So things that are same. Okay, so if we talk about a heterogeneous mixture, is a mixture that have different things. Homogeneous mixture, a mixture that have the same things. Okay, guys, so rocks and air are examples of two different types of mixtures, heterogeneous and homogeneous. It's not always easy to identify a mixture. A rock looks like a mixture, but air does not. Okay, guys, so air is well, I mean, you can't really see air, it's look invisible, but it's actually a mixture of different things. It's not just one thing. A heterogeneous mixture is a mixture in which the substances are not evenly mixed. Okay, guys, evenly is mean the same amount mixed. So let's say I mix two things. I have Coca-Cola and I have water, and I mix them together and I make half water, half Coca-Cola. Okay, so 50-50. That means they are evenly mixed. And that is not what this is. That means it would be homogeneous. Let's say I pour only a little bit Coke, 20% Coke, and the rest water, 80% water. Then it's going to be a heterogeneous mixture because it's not the same, not even. Often you can see the different substances and parts of a heterogeneous mixture with unaided eyes. Sometimes you can see them with only a microscope. Okay, guys, so what they're saying is sometimes you can just use your eyes to see, but sometimes you need to use like a proper microscope. Okay, so in the picture we have watermelon and we have cereal. Blood looks evenly mixed. Its color and texture are the same throughout. Suppose you compare two samples of blood under a microscope. They will look different. The samples will contain different amounts of components. Plasma, RBC, WBC, platelets. Okay, guys, so what they're saying is if you look at blood with just your eye, is look the same, like it's look the same all out. But if you look under a microscope, you can see is different. A homogeneous mixture is a mixture in which two or more substances are evenly mixed on the atomic level, but not bonded together. The individual atoms or compounds of each substance are mixed. Air is a homogeneous mixture. Another name for a homogeneous mixture is a solution. Okay, guys, so a solution and a homogeneous mixture is the same. Two or more substances are evenly mixed on the atomic level. Hey guys, how do compounds and mixtures differ? So what is the difference between a compound and a mixture? Okay guys, if you remember from earlier, a compound is if you take two elements and put them together. So like water. Water is a compound. It have H2O. A mixture is if you just mix two things together, but they don't bond. They don't become a new thing. So if you look at water, H2O, you have hydrogen, oxygen. If you look at only hydrogen, it's a gas. It's invisible gas you cannot see. And if you look at only oxygen, is also an invisible gas, cannot see. But if you put hydrogen, oxygen together, is look like water, is look very different from two gas. Okay, guys, so compounds, they become something completely new, is make something new. Whereas a mixture is just two different things that you put together and they just mix together. They don't become something new. The substances that make up a mixture are not chemically bonded. Mixing is a physical change. The substances that exist before mixing still exist in the mixture. Okay, guys, so what they're saying here, if something is chemically bonded, that means it becomes something new. So like oxygen and hydrogen is become water. It becomes a chemical bond. Okay, the other one is called a physical change. Okay, so physical is means something you can feel. It just means something real. So a physical change, if you mix two things together, they become into contact physically, but they don't change to become something new. Substances keep their properties. Substances that make up a mixture are not changed chemically. You can observe some of their properties in the mixture. Sugar water is a mixture of two compounds, sugar and water. After the sugar is mixed, you can see the sugar in the water. Oh wait, you can't see the sugar in the water, but you can still taste the property of sweetness. You can also observe some properties of the water, such as its liquid state. Okay guys, so what they're saying, if you mix two things together, the mixture that you get will have properties from the two things that you mixed. So in the example, they mix sugar. Okay, who knows? What is sugar?
is sweet.
Yes, what is name in Thai?
น้ำตาล
Namtan. Okay,
same
so
same
they
same brown in English.
okay. Okay, so we have sugar and we mix it with water. We put inside the water. And we stir. Okay, so you cannot see with your eye the sugar. It's just look the same as water. But if you drink, you can taste, it tastes sweet. So the mixture still has the sweetness from the sugar, and it still look like water from the water. So the mixture has properties from both of the old things. Compounds do not keep their properties. The properties of a compound can be different from the properties of the elements that make it up. Sodium and chlorine bond and form table salt. Okay, do you guys know what is salt? Salt is look the same as sugar, but is not taste the same. But people also put on food. Okay, guys, so salt
It is taste salty.
is taste salty, yes. But salt is made up of sodium and chlorine. So sodium plus chlorine is give you salt. But if you look at only sodium, sodium is a soft, opaque, silvery metal. Okay, guys, so just looking at sodium is look like a silver soft metal. And chlorine is a greenish poisonous gas. Okay, so if you look at only chlorine, is look like a green gas, poison gas. Okay, but salt is not look like metal or like poison gas, is look different. Okay, it says you cannot observe any of these properties in salt. So salt is not poison, is not gas, is not metal. Okay, so compounds do not keep the properties of the things that you use to make it. Does everyone understand?
Yeah, yeah, yeah.
Yes.
Okay. Mixtures can be separated. Okay, guys, what separated means is to make things become apart again. So let's say you mix salt and water, or sugar and water. Is mean you can somehow get the water and the sugar to be separate, to be different again. Okay,
Yeah,
the
it is same evaporation.
you can use evaporation is one way, yeah, because the water will evaporate, but the salt or the sugar not. The substances that make up a mixture are not bonded together. As a result, you can separate them from each other using physical methods. The physical properties of one substance are different from those of another. You can use these differences to separate the substances. Okay, guys, so what they mean by that is like if we take sugar and water, water can evaporate, but sugar cannot. So you can use these kinds of differences to separate the substances from each other. In contrast, you can separate compounds only by a chemical change that breaks the bonds between the elements. Okay, guys, so breaking a compound is a lot more difficult. Okay, guys, here they tell you a couple of different ways to separate mixture. So you can use a filter. Okay, guys, so what filtering is let's say you have like a wire that is like this, very close together, and it have small holes. And let's say you have water that have sand in, sand water, and you want to get the sand and the water to be separate. So you can pour the water through this like a metal mesh like this. And the sand will stay on top and the water will pour through if you make the holes small. Okay, that is filtering. Boiling. Boiling is when you make it hot. So let's say you have water and you have salt. You boil the water, the water evaporate, and you just left with the salt.
100 degree.
100 degrees, yes, for water. But different liquid have different temperature. Okay, and you can also use a magnet. Okay, so some things like metal have magnetic properties. So they will react, they will be attracted to magnet, so you can separate substances that way. Okay, combining substances, mixing and dissolving. Okay, guys, mixing is when you just put two different substances together. Dissolving is when the one substance, they mix very much together that you almost can't see the difference. So like if you put sugar in water and you mix enough, it's dissolve and you can't see the difference. Mixtures, matter that can vary in composition, made of two or more substances mixed but not bonded together, can be separated into substances by physical methods. Two types of mixtures, heterogeneous and homogeneous. Heterogeneous mixtures, two or more substances evenly mixed. Even mixing is visible with unaided eye or microscopic aid. Okay, and homogeneous mixture, also called solutions, guys. Okay, so solutions is the other name for homogeneous mixture. Two or more substances evenly mixed. Homogeneous mixtures appear uniform under a microscope. Hey guys, so the main difference is you can see a homogeneous mixture is look the same. Like in your eye, like water and salt together. If you mix together, you can't see like there's water, there's salt. Is all look the same. But with heterogeneous mixtures, you can sometimes see, the mixture. You can see there's different things in there. Okay, do you understand?
Yeah, yeah, yeah.
Yes.
Easy.
Yeah.
Yeah, yeah.
Controls. Okay, guys, what I want you to do today is on page number 13. Page number 13 in your books is look like this. Exercise 2.1. Okay, guys, there's just two questions there I want you to answer, and then you can just send it to me on Schoolbright.
Teacher,
Yes,
do 1 and 2 or do only 1, only 2?
do 1 and 2. But you have until Monday, so you don't have to be too fast. Um, Yeah, you'll be able to. I've put it up on Schoolbright, so you'll be able to see it on there. I mean, you can just send it back to me on there. And if you see the other people in the class, just tell them what they need to do. I'm gonna put this video up as well. They must watch this video. All right, guys, do you have any questions for me? That's it.
No. Teacher, physical can, when change to another one, can
Hey,
it will back to this one again or not?
Say again with if what change?
Look, ice melt to
Ice?
liquid, melt to a
Ye-
water. Then
Yes.
water can freezing to a ice. That is physical or chemical? Chemical.
No, that's a physical change.
Okay.
So a chemical change is something that will change the water into something else. It won't be water anymore. It'll change it into hydrogen and oxygen. You won't be able to get the water back. All right, Raksit, are you ready? All right, guys, that's it for today. I will see you tomorrow.
Yeah.
Bye bye.
Bye.
Thank you, teacher.
You're welcome.